Hello everyone, today we will talk about neural networks. So, neural network is a computational model inspired by how the human brain processes information. It consists of layers of interconnected nodes or neurons. So, neural network is a machine learning model inspired by the structure and functioning of the human brain. It consists of interconnected layers of neurons that are also called nodes that process and learn patterns from data. So, here we have the key concepts of neural network. So, first is the structure of a neural network. So the structure of neural network is like, first we have the input layer, then we have the hidden layer, then we have the output layer. So input layer consists of, it accepts raw input data. For example, an image in the amnest data set is represented as a grid of 28 cross 28 pixels. Then we have the hidden layer. These layers process the input by applying transformations and learning complex features. Then we have the output layer. This provides the final prediction of classification of amnest. We have 10 output neurons, one for each digit. Then we have the core components that are the weights and biases, activation functions, loss functions, and optimizers. So weight determine the importance of inputs, while biases adjust the modest predictions to better fit the data. And we have the optimizer, that is the algorithm that updates weights and biases to minimize the loss function. So up next we have training a neural network. So it consists of four steps, that is forward propagation, loss calculation, backward propagation, and weight updates. So in forward propagation, data passes through the neural network layer by layer to generate predictions. In loss calculation, the error is computed using the loss function. In backward propagation, gradients of the loss with respect to weights are calculated using chain rule. Then we have the applications. So image recognition, natural language processing, and time series forecasting are the applications. So up next we have the explanation of the code for neural networks. So first process is data pre-processing. In this, we normalize data. We scale pixel values to the range 0 to 1 for faster convergence. So so here we will do the classification, then we will do the train test split, that splits the data set into training and testing subsets. Then we will define the model. So our neural network has three layers: one input, two hidden layers, and with ReLU activation, and one output layer with softmax activation. So in model we have sequential dense activation function, that is ReLU, helps learn non-linear patterns by introducing 0 to negative values. And we have sigmoid out that outputs a probability between 0 to 1, ideal for binary classification. After that we have compilation. So we use the Adam optimizer for efficiency and categorize cross entropy loss, because this is the multi-class classification task. After that we will do the training of the model. So we train the model for 10 approaches, 10 approaches with a batch size of 32, using 10% of training data for validation. And then the model achieves a high accuracy, typically over 95% of the MNIST test data. Then we will do the prediction, that generate probability for new data samples. So let's look at the code. So here is the code. So first we will import TensorFlow STF, then we will import sequential from TensorFlow.keras models, then we will import dense flatten from TensorFlow.keras layers, then we will import MNIST from TensorFlow.keras dataset, then we will import two categorical from TensorFlow.keras utils. Then we will do the loading of the data set, then we will pre-process the data, then we will normalize pixel values to range between 0 to 1, as they have to be between 0 to 1. Then we will convert labels to one hot encoding, and then we will define the neural model. So first, in flatten, we'll flatten input images 28x28 into a 1D array. Then we'll then we will have the dense, that is the first hidden layer with 128 neurons. Then we have the second hidden layer with 64 neurons, and we have the output layer with 10 neurons for 10 classes. Then we'll compile the model, and then after that we will train the model. Then we will evaluate the model on test data, then we'll predict on new data, and then display actual labels for comparison. So let's run the code. So as we can see, the code is executed and we got the output, that we got our output with accuracies and loss. So yeah, so we have here predicted classes for first 5 test samples, and then we have actual classes for the first 5 test samples. So to summarize, To summarize, neural networks are powerful tools for solving complex problems, and their application to the MNIST dataset demonstrates their ability to run and classify patterns efficiently. They are the heart of many advanced technologies, from self driving class to personalized recommendations. Thank you. I hope you understood the topic.